All right. I think I should mute. It's okay. Okay, so today is a bit special day because I have finally reached Guardian on LeetCode, and in this stream, I'm going to share like all the topics that you probably need to learn to reach Guardian, and also specifically like things that will help you out to solve third and fourth problem on LeetCode contests. So yeah, where should I start? Um, I mean, I should wait probably. Maybe few people join. Hello Shubham Bhaiya, how you doing? Hello, hello. People have been like commenting. Okay, okay, bye bye. Yeah, like somebody was commenting. Where am I? Yeah, sure. Soon. Should I start? I mean, we can discuss the contest, the last contest that I gave. Probably like both of them. I was not able to give this, but I wish I could. Um, because it was actually pretty easy for me. I gave it virtually and I got rank around 600 around. Yeah. Let's talk about this contest first because I reached Guardian after this. So yeah. It was like just brute force, right? So if else conditions and if counter becomes 10, then break. It. I don't know why it took me like 5 or 10 minutes. How much time it? Oh, it took me 5 minutes. I should be able to solve this in like probably 2 minutes. 1 minute for reading a problem, 1 minute for implementing, but that's fine. I don't think there is too much to explain here. Yeah, this problem was a bit annoying to me because yeah, it took me a while. It took me around 20 minutes to solve. First of all, I actually hate solving problems that require some um, sort of extracting something from strings. So I also got TLE, not TLE, probably wrong answer. Can't see it here. Um, minimum flips. Wait, this is not the same problem. What the fuck? Yeah, this is the problem. Yeah, so basically they have given a string and the string should not contain these two things as a subsequence. So actually the main thing to realize here was that you could also have a string like this, right? So you can pick 1, 0 and 1 and it is going to be fine. And give me a wrong answer because it was because of that actually. I got wrong answer in like third example, so I did not submit, but yeah. There were like three cases, so either everything is going to be 1 or either is going to everything is going to be 0. You can also have one single one, then also this won't be generated if you have a single one. This is why you see O minus 1 here. And you can also have like everything 1. That is also the case. You know, and you could also have everything 0, right? But like this case is better, so you don't need to check it. And then this case, this was the crux of this problem, I believe. So you also check it and just return the answer. So that was it. So you have this points 3D space. So you have to like combine some subset of these numbers. I think this was a problem. Yeah, you have to generate like other k points such that target appears in one of the generation. And there is this target which also consists of like 3 points. So you will be performing this operation until you find this, or if you're not able to find it. So the only way you won't be able to find it if everything is repeating, right, in that particular iteration. And like constraints are pretty small, so you immediately think of kind of brute forcing it, and this is exactly what I did. So you can see here, this is like just a brute force. I have maintained a visited array, a 3D array, and I'm checking like if this is it. So if this is a target, then if target is already visited, then just return k. So k is like the number of iterations I did, and then I'm generating all the other points and pushing it back to this next array. Heavy edges. Light and heavy. Okay, so you have to go from source to target, and there could be like a multiple path to go from here to that place, but you have to choose a path which has like threshold such that at least one valid path. Okay, so you have to find minimum threshold. So this is binary search, right? Because if for some x threshold it's possible, then it is possible for all like x plus 1, x plus 2 threshold. Yeah. And you can use like, this is a graph now. You can use like Dijkstra to do this. Yeah, exactly. So I have used Dijkstra, maintaining a distance array and storing this in a queue. I could have used a priority queue as well, but that's... And you know, if distance, if like it is greater than k, then you just return false. Because to reach here, the number of heavy edges were like greater than... Wait a minute. Yeah. So this heavy is if weight is greater than x. Yeah, then I'm adding it. And I'm counting number of heavy edges. At most k heavy edges, yeah. So there should be at most k. So if it is like greater than k, return false, else true. So it was just binary search plus Dijkstra. Nothing much in this problem. It was very easy. If you know Dijkstra, you can solve it. Talk about this one as well. Although I was not able to give this contest, but I solved it virtually. It was pretty... I mean, just iterated backwards and push the elements. Don't even have to use a brain here. Just use a for loop. Yeah, this was a bit frustrating for me because, you know, I need to kind of separate these words, because single hyphen was allowed, right? So this is not allowed because after this you needed like both lowercase letters. So yeah, it took me a while. This is just checking whether the number is a character or not. If it's not a character, that means it is a simple dash. Is this called hyphen? Probably. Yeah, it took me a while. I don't like solving these kind of problems for a reason, because you have to think of a lot of edge cases. I solved it like immediately because you have to reduce the sum and you can replace this number if the mod is there. So basically for every single element, you have to find the lowest, the smallest element that is dividing your current element and that is also present in the array. So basically you can use like n root n solution, iterate through like root n and then finding all the divisors, right? And if you're able to find it, if this I is a divisor, you just return, right? You just break the whole loop because that is the answer for this particular element. Else if this second pair is the answer, then you don't break it because second pair is going to reduce as you go forward, and vice versa for this pair I. Yeah, I got a wrong answer. Probably I missed something. Yeah, I missed one because one can also be in the array, and I was forgot that case. I could have also did like after sorting, if the first element is 1, then just return n, because then one can basically anything mod 1 is 0. So minimum cost to buy apples to. This was very interesting because it has like two parts. First, you can go to any node, right? Then you can buy it and then you can come back. So going to somewhere is basically Dijkstra, right? And coming back from something is also Dijkstra. It's just like a framing of a problem, right? So you have to do it twice. I got wrong answer multiple times. So it's basically, you can, by the way, you have n square to solve this. So for every single node, you apply Dijkstra inside, which is n log n, and you apply it twice. So I think the mistake I did, I was thinking that this particular returning cost is actually the accumulation of cost into the particular taxi. Let me see. I don't know what I'm talking about. Yeah, so I thought it's just like a summation of everything, right? I thought it is like cost into summation. So it gave me a wrong answer. Then I made a graph. I have seen that this is not the case. It is actually the multiple of cost and whatever the tax is given for the specific edge. Then you can iterate to all and you can see whatever is minimum, right? So if j is equals to I, then your cost is 0, your tax is 0, then you only get price. So it basically explores all the cases. You store the answer. Easy. Should I just give like a brief overview? Maybe like all the concepts that are probably required to reach Guardian to solve like C and D problem. Helpful. I don't have a lot of time, so maybe I'll just explain things and I'll just end my stream. Okay, so first thing that you need is maths, and it's actually very important to be good at maths, especially to solve greedy problems where you have to also prove your solution, and maths is always going to be useful. So there are topics in maths that you should be comfortable at. For example, modular maths, right? And things like divisors, like find divisors in like root n, you know, because divisors exist in pairs. So yeah, and what you should be aware of little format theorem, right? I think the spelling is wrong, but that's all right. And what else? You should be aware of like some binomial properties, right? For example, NCK is basically, should be able to map it to like Pascal's triangle, because it's helpful if you have to simply calculate this NCR thing, right? So it is basically like your NCR is going to be what? N-1 C R-1. So this is basically, you are picking one less element so that you can pick. Yeah, I'll explain this. Quickly do this. So this is a property of Pascal's triangle. Like this is how they are related. And R. Okay. So let's say you have some elements, R-1 elements, and this is a like another element. Right. So there are total R elements. These are R-1. Right. NCR is basically picking R elements out of N. Okay. My bad. These are all N elements. And you want to pick like R from them. So you can consider this thing in like two cases. So see, this one you can either pick this or not pick this. So this term is basically picking R-1 from these. So you are not picking one element because that one element is this one. So this is the case when you are picking this element. And this is the case when you are not picking this element, you are picking all the R elements from this. So this covers like all the possibility for NCR. That is like Pascal's triangle. This is your DP recurrence, okay, for Pascal's triangles. And what else? You can also prove like little formats theorem. Not VS Code, I forgot. Right. So if you have something like, if you have to do like A upon B, some mod, some prime number is a prime number, then you can do like, so you can rewrite A upon B into like A to the power, A into B to the power -1 mod P. Now little formats theorem is basically this B to the power some prime number -1, and if you'll do like, so this is congruent to 1 under modulus of P. So this is a property. So if you'll do mod -1, B to the power mod -1, this is going to be congruent to 1 under mod P. So you can use it to calculate it. Just multiply it by this P -1. So A into B to the power -1 into this number. This will give you A into B to the power P -2. Right? And everything is happening under mod P, right? This is only valid under mod P, remember that. So you can do this, you can simply multiply it by this number rather than dividing, because dividing under modulo is, it is going to give you wrong answer. You can also prove this. So we can take an example, maybe let's say prime number something smaller, 5. Let's say there is a number, let's say it's 3. Let's say it's 3. Okay. So let's consider all these numbers 1, 2, 3, 4. Right? So till like P -1. I have already written everything till P -1. Now if we will multiply 3 to every one of them, so just multiply by them A, and you will get like A is 3, so you will get something like 3, and 3 2 just 6, 3 3 just 9, 3 4 just 12, something like that. We will do mod, right? Let's do everything under mod, okay? under mod P. If you will do mod P, so individual mod 3 is going to be, this is going to give you 0. This is also going to give you 0, which is wrong. Two is 6, 3, 3 is 9, 3, 4 is 12. Oh, under mod P, under mod 5. This is going to give you 3. This is 6. This is going to be 1. This is 9. This is going to give you 4. 12 is going to give you 2. So you'll see this. This is actually equal to this one. 1, 2, 3, 4. It is just rearranged into a different form. And not a single element in this is going to repeat, because basically A is not divisible by P, right? P is a prime number, so basically A mod P is not 0. So this is going to be congruent to 1, 2, 3, 4 under mod P. So you can do here, you can write this 3 as 1 into 3. Wait. Yeah, you can write it as 1 into 3. You can write this 1 as 2 into 1. So 2 into 1 is 1. And 1 mod 3 is how much? 2 mod 3 is 2. Wait. I need to be a bit careful here. Can we multiply here? How can I prove it? So we have 3, 1, 4, 2, 1, 2, 3, 4. It should be satisfying some mod property. Yeah, so we can write this thing as, so this 1 is nothing like, we can write it as 1 into 4. So 5 mod 4 is still 1, so that is correct. We can write 2 as 2 into 3, because 3 to just 6. Mod 3 is, mod 5 is 1. Very confused right now. Yeah, this is correct. And we can do like 1 into 2 is going to give me 2, which is absolutely wrong. Then I can do like 4 into 3, and then I can do like 2 into 4. What is this? 4 to 8. It's 3 actually. But then this is wrong. 1 mod P. This is a correct proof. Three threes and 9 is how much? Need to find a way to rewrite them. So these two are same combination. Can I prove it? What is 4 into 3? 4 3s are 12, which is going to give me 4 3s are 12. What is 5 3s are 15? Um, so to prove this, what do I need? I need something like, so I need something like a to the power p minus 1, right? This should be congruent. So also let's be a little bit more specific. This will be equal in this case when you're multiplying like everything under mod p. So these are going to be congruent. And then we can rewrite it as, we have to rewrite it. So this 3, how can we write 3? We can write it as 1 into 3, right? Yeah, that's fine. Then we have 1. How can we write 1? Two 2s are 4. 2 into 3, because 3 2s are 6. Mod 5 is 1. That's okay. Can we write 4? It's going to be like 2 2s are 4. In terms of 3, we can multiply 3 with by 3, right? Okay, I think this is going to work. Then we are going to multiply 4 with again 3. 4 3s are 12. 12 mod 5 is 2, right? Okay, this is the proof. Okay, so I have rewritten these terms as this one. These are also congruent to this thing under mod p. We also specify, right? Now we can take this 3 common, right? So this is going to be 3 to the power, it is coming p minus 1 times. So this is 3 to the power p minus 1. And then we are going to have 1 into 2 into 3 into 4. Right, under mod p, they both are congruent. Now, this is basically 4 factorial. So I can replace it with 4 factorial. This is also 4 factorial. And these 1, 2, 3, 4, these are basically numbers from 0 to p minus 1. So they are not going to be, this number mod p is not going to be 0. So you can cancel these terms out. If you will cancel them out, make it a bit bigger. So if you will cancel them out, you will get something like this, right? And 3 is what? 3 was a. So we have actually proved that a to the power p minus 1 is congruent to 1 under modulo p. Now we can actually use this result here, here to calculate a upon b mod p. I've already explained it. You can just multiply it by b to the power p minus 2 to solve. And what better, what should I do like approach? So first of all, you should be, maths is required if you're solving like third and fourth problem. Sometimes it is also required to solve second problem in a contest. So make sure you are good in maths. You can think of proofs, and most of the problems, especially on code forces, they are not about some sort of algorithms. On LeetCode, algorithms are very important. Your Dijkstra, DP, I mean DP is absolutely, it's very important on all the platforms. Things like segment tree, fanfic tree. For LeetCode it is very important, you should be aware, and I'll be discussing about those one too. Right now I'm just discussing about basic maths, right? So these are the things you should be aware of, and let's add some more things. Counting is very important, right? Permutation and combination. So like this was like in class 11th, but this is class 11th maths. If you have prepared for JEE, then you should be good at it. And counting is used like on a lot of problems, right? Even like I can show you like some previous problems where I have used counting specifically. Not this one. I'm not sure which one, but there was a problem. It was some sort of a tough problem. A copy, so maybe I can find it. Yeah, this problem. So here you actually have to make pairs, right? So nah, this is not a problem, sorry. I don't know, it was somewhere. This is not the one. Yeah, this is the problem. Yeah, this is basically wrong. Okay, so this problem, see, first of all you should know like how to use DFS, you know, like a very common thing. Got your point? Yeah, and you should also like solve problems on code forces. That is going to help you to, you know, build your intuition, because these problems use a lot of concept. For example, this problem, it uses like DFS, right? Then it uses the concept of combinatorics, again permutation and combination, as I discussed. Because here, once you know like these are the number of groups that you have, now you have to pair those groups. So this is wrong, right? It is not like multiplication. It is basically, you have some groups, let's say this is the size of these groups. Now you can use any element from this group and combine with any one of them. So essentially it is going to be 2 into a total minus 2. So 5 plus 4 plus 3 is 12. And then you will sum this up with like 3 into these ones. So 5 plus 4, 9. You won't consider 2 because 2 has already been paired with everything. To understand this, first of all, you need to read this problem, right? Read it, see why do we need like these groups, and then come back. So right now I'm just telling you the importance of maths, because without maths you won't be able to reach Guardian at least. Yeah. Then it is like 4 into 5. And then last one is just 0, because you have combined this 5 with every single one of them, right? You can also see this as, you know, 2c1 into So you're picking one element from 2 and then like total minus 2 even something like this, and then you can do like summation, and both are like the same thing because 2c1 is just 2. Solve like 1300 1400 more, I would say. I got it, although just started array. Bro, 4 days, this is going to take a lot of time for you. So just be ready to work hard and, you know, solve at least one problem every single day. If you will go check my profile, most of the problems that I have solved are actually hard. Even the mediums that I have solved are hard problems, and I did it because I could. I can easily solve easy ones. So to me, it's not beneficial to do it like again. Because easy problems are not going to teach me anything new. Like on Code Forces, I am currently solving 1700s, and I can solve 1700s like 60-70% of the time. Although I'm very inactive on courses nowadays. Okay, so this is counting. Is there anything left? I mean, binary exponentiation, that is also very important. If you have to find a to the power b, so rather than doing like a into a, you know, like 3 times, we use binary properties. So this b can be written as some like binary number. So basically, if you have like a to the power some number 5, you can write it as a to the power, what are the binary numbers? A to the power 1 into a to the power 4, right? Yeah, so you can write it as this. And if you have like a very big number, you can, if it is under like long range, then you will have at max like 64 of these. You have to do this like 64 times at max. So you can initialize your result as 1, and you iterate, you use a while loop until your this number, let's call this 5 as b, right? Until this b is 0. You keep doing that, you maintain this factor, keep multiplying every time, and you shift this b to the right and keep checking bit again. Like bit is 1, then only you apply the operation to a to basically add into your resultant. So binary exponentiation is also very important. So I think this is pretty much maths. Let's go to some other topic. Go to DP, okay. So in DP, I mean, you should be able to recursively write the solution. Not recursively, but iteratively, right? Because a lot of people write solution recursively. Any advice to push? See, when I was solving 15 to 1600s, most of these problems, sometimes they are some binary search problem. Sometimes they are like some Manhattan distance where you have to separate and solve them independently. Sometimes they are like some mean or mod, like median problem. You have something, there are people in a number line and you have to travel to minimize the cost. You can use something like median. I mean, there are a lot of techniques under this range. How I did it, I've been solving like A to J ladder, and also TLE31 CP sheet. It's also a pretty good sheet. I will recommend you to like solve these two at least if you're at 1300. solve this one like 13 and 1400. That is going to help you, right? Right now I just do like this A2OJ whenever I get time. Although right now I am very inactive on code forces, but I like try. Right, we will solve some problems after I have done explaining, right? Okay, and there are also some DP optimizations. For example, prefix optimization, right? So this is the like the most common type of optimization, usually like used in fourth problem. I can also like show you some examples, but yeah. And what, there is also like something like divide and conquer technique. Honestly, I'm not good at DNC, so you probably don't need it. And convex hull, I just don't know convex hull. I just know like convex function has like a single global minima, so we use some sort of a technique to reach to that minima. But I'm just not interested to learn it because it's usually like above 20,000 rated on code forces, and I'm not at that level right now, so not beneficial for me to solve that. And there are some special techniques in DP. For example, there is something called digit DP. Okay. And there is some, you should be also aware of bit masking in general, not only along with DP. And what else? I mean, not bit masking, like simple masking. I'm forgetting things. Now college, you don't have to make notes. You know how my notes looks like? This is probably my 5th copy. These are my notes while solving a problem. This is how my notes look like. I love like the whole copy, and this is the 5th one, I believe. Skincare. Yeah. I use a moisturizer, a sunscreen, and also I use aloe vera gel at night. Much. Nothing more than that. Thanks for asking. Tips. I mean, what tips I can give you? Are you like comfortable with maths? Are you comfortable with proving things? Like the way I proved this theorem in the spelling is incorrect. Alright. Are you good at like mathematical thinking? Because DSA is all about like very similar to how you solve a problem in maths. Because maths problem also have patterns, they also have formulas. Formulas are just algorithms, right? Patterns are basically, you know, you will only learn patterns when you will solve problems by yourself. I cannot teach you. You are okayish, that's cool. How can you do better? I mean, the only way to get better is to solve problems. Maybe I'm like telling you these things. If you're missing something, you can probably learn, right? Yeah. So digit DP, masking. What else? Like on the spot चीज़ें याद ही नहीं आ रही मुझे. There is something called SOSDP, subset over sum. I mean, and like you should be aware of like how to find LIS in n log n. Right? This is going to help you. A lot of problem involve this particular concept. I'm pretty sure I'm missing a lot of topics here. I'll also write DNC just in case. Also like optimization, including priority queue. That is also going to help you. What else? Make sure you can think of recurrence. That is very important. You can think of a recurrence, you can solve a DP problem easy. Sweep line. Yeah, sweep line is also important, but is it a part of a DP? It is like basic thing you use whenever you have given a problem and there are points, then you use like line sweep. So sweep line is a good one. There are some special properties of XOR. There are a lot of problems that involve this technique, like that involves this XOR property. And the good thing about XOR is, first of all, it is invertible, right? So you can use like prefix some sort of technique, right? Which simply means you can use fan victory as well. With XOR. And yeah, these are two main things about XOR. And or they are not very special, but like XOR is special because of this property. Is there anything else? My face is hiding it. Oh, my bad. But then I will have to invert it as well. How can I invert? Maybe. Here. Scaling and aspect ratio, I think nothing there. Color correction, I can't find it. Bean properties. Where is the option? Can't I just mirror it? I mean, this is alright, I believe. Yeah. Keep it this way. Okay. Now you will be able to see it. Enough about XOR. So like AND and OR are not very special, but like XOR was special, so yeah. Next is what? Try. So you should be able to, let's start with like algorithms, right? You should be aware of KMP, very important, right? Z function is also similar, so if you know KMP, you know Z function. Maybe hashing, sometimes it helps when a problem is not very strict. There's an algorithm in hashing, like basically same thing. Else, like try, sort of like prefix and suffix matching. That is also very helpful. Yeah, let's talk about try. You can use try here as well. To find like maximum XOR with some element X possible. By the way, there is also a technique in XOR which is called XOR basis. So technique is simple to like basis in vectors, and if you don't know about this, you should probably, this is gonna help you to find maximum XOR subset sort of problems. You can go to UCCO guide. Got placed this month. You? Congratulations, bro. It should be somewhere here. XOR basis, yeah. This is a very simple technique. This is not hard at all. Just make sure you understand it and then you can use it to solve problems. There was a problem on LeetCode which requires this XOR basis. I remember. Yeah. Is it? You know, like subsequences, bagera, all those things. And this is also cool. Is left. Let's talk about greedy, right? So if you will look at harder problems, even the problem is of DP, but you some sort of need that greedy thinking, right? You need to think of like what is the most optimal way, right? Right. And if you're good at this, that simply means you're going to be good at every single thing, right? Maths is different, but you will be good at every single algorithm because then you can think, deeply. You can think of optimal solutions, etc. I've been trying LeetCode shopping offer problem. DP is intuitional but still stuck. Shopping offer. If you're not able to do this, even after months, you are probably solving a wrong problem. Solve easier problem. Is it a hard one? It is a medium problem. N is very small. If you're not able to understand it even after a month, probably let it go for like 1 2 more months. Then once you're comfortable, you can come back and see the solution. This is what I can recommend. Right, so this requires a lot of practice. What I did is I did like LeetCode hards and code forces around 1400, I would say, to 1500 rated questions, right? It can help you out with greedy. And usually, like, if the problem is greedy and it is hard, I'm usually scared of hard greedy problems because that is basically div 2D, right? Like, I can solve like div 2D probably like 30% of the time, so not really good at it. And it's usually like 1800 range. I believe in probably next 2 months I'll be good enough to solve D, and I'll probably hit expert then. But so what else? Hmm. I mean, we can talk about graphs, right? So like BFS, very very easy to think. Dijkstra, right? What else? Like 3DP, that is also very important to, if you want to solve a hard problem. Thing is, map high level idea. I can try, absolutely. Let me try. There are at max 6 items. Every single one of them has a price. And a special offer consists of one or more different kinds of item with the same given addition. Need number of pieces of item I want to buy. Special of it is size of n+1 number of pieces. Number of pieces in the ith offer. Price of the offer. So you can basically buy 3 pieces of this. Wait, what? Price. Pieces. You'll buy these pieces, you will get this offer. Lowest price you have to pay for exit. So we need to buy something, okay? Like specific number of items. All right. And there is a price of every single item. Like, so price is there. So if we don't have this special, then this is basically 2 into 3 plus 2 into 5. Very easy. But we have given this special array. We can use this offer. So in this example, we can use this offer and we only have to pay price of 5, which is better than paying 2 3s are 6. Yeah. Helpful. Then we have to buy 5 of these. You cannot buy 3. You can use this. This is 12. This is 10. So this is optimal. See, we can use like special offer. If quantity if quantity of ith item is less than required, less than or equal to. These are like some observations that you will make first. You cannot do this because 3 is greater than, well, we need 3. I'm sorry. You either choose this one or you either choose this one. Then rest of the items you are going to buy by yourself. Okay. What is the size of this particular thing special? There are 100 of them. So you need to find like some optimal way to use offers. Let's think about it. Is sorting gonna help? We sort and do it. You may pay 3A and 2B. You may pay $10 for 1A 2B offer and 4 and 2A. Wait, why is it 14? I got this quantity for 10. Now how much I need? I need 2. Only need 2, which is 4. 10 plus 4 is 14. Okay. See, if I will use this special offer, okay, let's talk about recurrence and DP. If I will use some special offer, what is going to be my DP state? So it depends on like in which way you solve. Either you go like bottom up or top down. Let's consider you are at some state I and J. I and J is basically the number of items, right? You need a big array for this, but like n is going till 6, so you can do it. So these are the quantities that, let's consider these are the quantities that are remaining. It is going to be dp of I plus q, whatever the quantity is, a plus q, and plus price. See, the quantity was this before, right? So it was like this number I plus q. This was your quantity before. Once you have used this special offer, right, your quantity is going to reduce to I, right? It will be like minus this number, and similarly for other items. And the cost of this operation is going to be price, because now you have to pay price, right? So this is the offer price, by the way. And then you have to find like minimum of it is going to be it. So until 6. Offer can be used multiple times, is it? Special offer consists of one or more. You are not allowed to buy more items than you want. Okay. Hi Abhay. So we can use offer any number of times that we want. So you will have to make some changes here. How can you handle this? Hi Noor. If you will do this recursively, then it's very easy to think. You just keep iterating on the same index. But if you're doing it like iteratively, then you will have to think about it. I can use it as many times as I want, and price and need is less than 10. If it is less than 10, Just like iterate the quantity, I believe is what you can do. This is what you can do. You can pick it once, twice, 3 times, 4 times, but it doesn't make sense to pick it more than 10 times, right? Because somebody will be there and it is going to exceed your need. So this is something you can do to solve this problem. It would be good if you do it top down recursively. I'm more comfortable with that. I mean, you have to do the same thing. So top down, you will start like from zero need. Say you are starting from, you're starting from zero. So this is like 0 items you have right now. Right? Iterate over special offer inside recursion. Let me give you a template of it. So you have some states. You will iterate over all special offer. Your base case is going to be like if like your first variable is greater than whatever your need, or like j is greater than whatever you need, then you have to return, because those are invalid cases. That is going to be your base case. And you iterate over all special offer every single time, because you can do it again and again, right? And again, you can go to like I plus whatever the quantity, similarly j plus quantity. The only thing you need to worry about, if n is 6, then you need 6 of these variables. So a good option is to create a array, create a vector to handle this properly. Yeah. And also this thing that you can do it multiple times, this thing is going to do that. If you will iterate over all special offer, this is going to do the same thing. You have started LeetCode. I would say that learn some mathematical concepts. I just remember something. You should also learn sieve. You know, it helps to like calculate, like you can get like all primes till n in like n log of log n. And the technique that is used in sieve, it is actually used in a lot of other problems too. I've used it like in yesterday's problem I was solving. It was a 1700 rated, and the same concept was used. Yeah, you go here and you make like cost equal to 0, and whenever you go to some state, you also plus the cost. And if you are here, you will return like int max, okay, because those are invalid cases. Right now, if I equals to need and j equals to need, right, then you will return then you can return 0. And here you will have to take minimum of all right, and here you can return cost. So this is like a template. This is how you will do it, okay? And then also like memoize it so that it is much more. I wonder, do you even have to memoize it? This is always going to be the case. And need is only going till 10. You probably don't even have to memoize it, right? Because this is less than 10. So any single state will go through this recursion at max 10 times. Then it is gonna come back from this base case. Take this as int max. Right. By the way, also, this is not 100% correct because you might not be able to get your need. Okay, once done with recursion, you will iterate over it. Okay, you actually will have to store this in a table because you will have to iterate over it again. Then if you're iterating over, let's say IS5, J6, and you need 7 of I and 7 of 6, then you will have to do +1, right? +2 here and +1 here. Then you will have to multiply it by the price because you have to buy it without using special offer, and you have to do it for all. Then only you will get optimal answer. So this recursion itself is not enough, I believe. I mean, make sure you do this. You have to do this to get an optimal answer. Backtracking and DP. I mean, this is a good problem. So you're iterating over all the special offers. Oh, so you can do it like over here as well. Acha, so basically while backtracking, whatever you need, you're doing this. So apart from doing this iteratively, after this recursion is done, you can also do it like while backtracking because you know how much you need, right? Okay, that is also possible. All right. It is actually, I would say you are not able to understand it because this is actually a good problem, I would say. Because it also requires you to think of backtracking because you have to do this as well optimally. Because it's not like you are only going to use special offer. It might be the case when using the special offer is going to give you more price. This is why while backtracking, you do this, right? Also do like need minus I into price. Take minimum. Okay, this is your whole algorithm that you need. You don't need memoization in that case. Okay. So it is non-zero. At least one of special is. Acha. So everything is not zero. Fine. Because then you will be stuck. Yeah. I think this is, you can solve this problem this way. I was stuck at that part. How am I going to maintain the needs state? You don't have to memorize. You don't have to memorize in this problem. Are people memoizing this? I don't see a memoization here. People have just made these functions so that they can just call a function, you know. Shopping offer is the main function. See, you have to maintain a vector as I said, like for this indexing. Vector for needs. You were asking that how to maintain needs state. This is how you maintain needs state. If you're taking this special offer, then your need is going to increase by the quantity, whatever the quantity is given in this. I have already said use like a vector, because these can go from like 1 to 6. So use a vector to do that, and you don't have to memorize anything, because see this condition, need can be at max 10. So any state will only go through recursion at max 10 times. Yeah, there might be a situation you have 0 0. If you have 0 0, then you can do pruning, right? That's it. You don't need any sort of memorization here. Okay, we were talking about graphs. So what else? There is a very good guide on code forces. EFS tree, yup. Actually, you should be aware of bridges, articulation points, and what else? Missing a lot of things. Yeah, so this is a very amazing guide. If you guys are already comfortable with graphs, then only I would recommend go ahead and learn these amazing techniques, because you can use DFS to find like bridges and articulation points. You don't have to worry about those Sargent's algorithm type shit, although like things are very much similar, but this gives you a pretty cool intuitive understanding. Right? Just maintain like a visited set uh, for for like for like detecting a cycle, etc. You use DP, right, to see like bridges and articulation points. Is actually very good guide. In 3DP, we have binary lifting is very important. So what binary lifting does is basically stores distances in like power of 2, and how we calculate it is basically, if you want to go like from current node to some node that is some 2 to the power up, 2 to the power n upwards, you can go first, you can go to the node that is 2 to the power n minus 1 above, and then you can go to the node that is 2 to the power n minus 1 above that node. So this is binary lifting. I'll accept it right away. Well, um, Ayush, is this you? Ayush, who is this guy? He's Knight. Harsh. Are you Harsh? Going on. Okay. You. You are already specialist. That's good. I'm also specialist. But like I am not giving contest anymore. I don't know why. Right now I'm focusing more on LLD development part. So yesterday I was working on this Zomato system design. Not even loading right now. Took a break. Bhai, I could solve it. I don't know. I could solve 1600s, but I'm still like not expert. I think I need to lock in for like 1 or 2 months, then I will probably reach expert. I don't know what's wrong with LinkedIn. I'll accept it. Okay. It was binary lifting. We also have a lot of other things in 3DP. But like, let's call them, applications of binary lifting. LCA, right? Senses between two nodes. These all things can be done like in log n. Okay. Okay. Lowest common ancestor. How do you find LCA? Else. This is pretty much all about binary lifting. Let's go to RMQs, which is range queries. So like segment tree is like a father of everything, right? It can be used for like invertible and non-invertible operations too. Okay. Addition, XOR, min, max, GCD, everything. Then we have a fanvic tree, which is like faster, but it uses like prefix sum, so it like requires invertible operation. Is there anything else? You can learn sparse tables. They can find min max in like big O of 1. Okay. And it is possible because we don't care about um, updates, and also overlapping. This is why you can do this, although you have to pre-process it. So pre-processing is required, but then you can answer queries in big O of 1. Is there anything else? I don't know. um, Comfortable at segment tree from Code Forces Agile. Yeah, that's a good resource. Also check out CP algorithms. That is also good. Sure, you implement it like yourself. Segment trees. There are a lot of forms of segment trees, like advanced forms like persistent segment tree. There is also beats, and right now I have no idea about them. I know when will I need like persistent segment tree, but I don't know how to implement it. So yeah. Is there anything I'm missing? I have my templates. I will have to use my passkey. Yeah, can't use. Wait. Uh, okay, I have my phone. and number of hearts, I guess, but I have to be consistent. This is what you need. You need consistency. And I have actually few interviews scheduled. Actually, a one interview, but it's a good offer. So right now I'm learning things like SQL queries, some core part as well, and again LLD. So I'm not able to focus that much on CP. And also like college work, practicals were going on. Today was like my last practical. And from 22 I have exams. So yeah. CP templates. I may find something here. Fenwick, yeah, there is PBDS as well, right? So PBDS can help you to find like number of elements smaller or greater. Yeah, DSU, of course. I mean, there is graphs, right? You should know DSU and also like advanced form, right? Involving addition and XOR, that is also required. I think this is called like weighted DSU, I believe. There we go. Already have it. We have like Manikers, right? String algorithm. We also have Maniker. Although not required at this level, but you can check it out. Yeah. And after my exams in June, I will be free. So I will be doing like a lot of CP. If you will open my code forces, it's not logged in. So in Jan, I was free. I have solved a lot of problems in Jan because I was free. Every day I used to solve like 3-4 problems of like 1500 rating around. Yeah. Maximums or strings, the algorithms, binary lifting. Already explained this. NCR, we can use like, if we want to do it efficiently, then Pascal's triangle, I have already explained it, or just use little Fermat's theorem with mod. Yeah, I think this is pretty much enough. Is there anything else that I need to discuss? Right, very important. You should like deeply able to understand this. There's a lot of problems requires you to think some of prime multiples involving LCM and GCD. So one simple property is like LCM is basically GCD of, let's say, A into B into A into B. You can use that property as well, but make sure you understand, because is basically if you have some numbers, so they, if you have some prime factors, GCD is going to be the prime factor into the minimum power, like vice versa for LCM. I thought like everything is gonna get. Anything else? Yeah, thank you, Harsh. Thanks for coming. Really appreciate it. Just make sure you practice every single day. Don't get demotivated and do not solve problems that are like much harder. If you're not able to understand the solution, then make sure you just leave the problem, right? Do it after 1 month. Just don't waste your time. Solve problems that you could like, maybe you're missing like one thing in the problem, right? Those type of problem you should solve. So, at your rating, around your rating, I would say. Yeah, you can follow CP31 sheet, or you can simply go to A2OJ and just solve some B's and C's. Make sure you look at the rating so that you solve the correct problem. Or you can simply sort by rating on Code Forces by itself. It's also going to help. I think that is enough, right? Cool. And like, I would say like maths is one of the most important thing. When I have started, I was already good at maths. Like these all things I was already aware of. And it helped me a lot because then I could learn things much faster at my brain. Like I could learn C very, very much faster because I know like about pairs of divisors, etc. things. Is there any other like special DP type? No. That's it. There might be more algorithms like sweep line. I mean, if we talk about like hard problems, they are just like combination of these things above. That's pretty much it. Yep. And this is like the most important. If you're good at greedy algorithms, that means you are going to be good at code forces, and that is going to help you to solve like LeetCode third and fourth problem. Then you just have to focus on learning these algorithms, try, etc. That is it. Use like CP algorithms and USECO guide to learn these topics. You may also find like some good YouTube videos. So I think that is it. I should probably end my stream. Solving problems. Easy for me. Hamburgers. Bottom to top. So you start with like we already have like ingredients, and he has some money. Like, are we going to buy? The shop nearby has all three ingredients. Okay, is there any limit? Cannot break a slice, so everything is atomic. Shop has an unlimited number of pieces. Okay, what do I have to find? Maximum number of hamburgers he can make. So you need like 3 breads, 2 sausage and 1 cheese. So you already have it. And I have to maximize burgers. Maximize. So if I can make like some X burgers with amount of ingredients I have and the amount I can actually buy from the shop. If I can make X, I can make X minus 1. So I can binary search on like the number of burgers. Um, doesn't exceed 100. I ultimately need the count. I need the count of burgers. I need the count of sausage. I need the count of cheese. That's it. I don't care whether the size is 100 or 1000. The amount of burgers he can make is basically some linear combination of this thing. So if you need 3 breads, it's going to be 3b, 2 sausage and like 1 cheese. Okay. And every single one of them has a price. Okay. So it is going to be P of I, VPSPC, this is cheese, this is sausage. This is like the price. Okay. The amount depends like on the factor, how much we can make. I can make a linear programming equation out of this. Let's think of like binary search. Okay, there will be a boolean function value x. So x is the number of burgers that we want to make. Okay, burgers, we need like 3 into x burgers, we need 2 into x sausage, we need like 1 into x cheese. And we already have something. We have sausages. What else do we have? So required, required burger is how much? that is going to be whatever we need. Okay, it is going to be 3 into x. This is how much we need. We subtracted subtract with what is available. So these are the amount of burgers that we definitely need. Have to buy them, and the price to buy them is basically going to be two price of burger. We have to do it for all three. Right? If total price less than or equal to R, return true, else return false. I think this one out. So we have let's check it for 4. Okay, so 4 threes are how much? 4 threes are 12 minus how much do we have? We have 1, gives me 11. And we're going to multiply it by the price. A minute. I have 6. So I only need 6. The price is 1. Similarly do for sausages. So how much sausages we need? To just 6 sausages. How much do we have? We have 4. This is going to be 2 into 2. 4. This gives me 6. Right. This is already incorrect. So it is true for 2, right? Why I'm checking for 4? Let's do it for 2. What is 6? So we need 0. We already have enough, so we don't buy anything. Need 4 sausages. We already have 4, so again this is 0. C is 1, so we need 2 of them. We have 1. We need 1. 1 into 3 is 3, so total cost is actually less than that. If this was 3, right, then you could have like 9, 6 and 3. 3 into 1, and for this you need 2 into 2, which is 4. For this you need 2 into 3. This is already 6, exceeding my price, so this is not going to work. 2 is the answer, and I think this is the solution. Yeah. Binary search, I'll do it later on. We placed not right now, but I have a interview scheduled for Infosys L3 offer, 21 LP offer. Let's see what happens. I'm actually doing LLD and SQL right now, like window function in SQL, and designing like systems, low-level systems. I think that is going to help me in the interview. Low-level design. I was talking about LLD. My core subjects are already very strong because whenever I learn something, I always ask this question like why and how. Right? So if you're learning about like virtual memory, you should ask like why do you need virtual memory? What are the type of problem it is solving in operating systems? That really helps. Hi Shubham Bhaiya. I think I'm done for today, right? I think I have covered most of the things here. You probably don't need these two. Very rarely LeetCode asks questions about bridges and articulation point, but the guide on code forces is actually too good. Make sure you check it out. It is also most important. It is also more important for medium problems too. Right? Usually problems are like combination of some greedy, some optimal way, and some other approach, some other algorithm. So is it? Yeah. I'll probably stream tomorrow or maybe not. I'll see. Yeah. Bye guys. Yeah. Soon. Hopefully.